In this video, we will learn the basics of asynchronous programming with async await in Python, which is an important topic in modern Python programming. According to Python documentation, coroutines are a more generalized form of subroutines. Subroutines are entered at one point and exited at another point. However, coroutines can be entered, exited, and resumed at many different points. Actually, coroutines behave quite like generators. In the early versions, coroutines were defined by generators, which are called generator-based coroutines. In modern versions of Python, coroutines have become a built-in feature and can be defined with the async def syntax directly. As you see, the definition of coroutines is very abstract, but the usage is actually very simple, as will be demonstrated soon. As mentioned in the previous slide, we should use the async keyword to define a coroutine function, which is also simply called an async function. When the async function is run, the code in the function body will not be run. Instead, a coroutine object is returned. And if we run this code directly, we will see a runtime warning saying the coroutine was never awaited. From this example, we can see that the coroutine object is the object returned when running an async function directly. The coroutine object should always be awaited for the code to run properly. So let's await the coroutine. Note that a coroutine can only be returned in an async function, which means the await keyword must be used together with the async keyword. It's a common practice to create an entry point main function where the coroutines will be awaited. However, where should the main function be awaited? It seems we enter an infinite loop here. Actually, for the top-level entry point coroutine function, like the main function in this example, we need to use async io.run. To run it, note that the coroutine object is passed to async io.run, which means the main function should be called here rather than passing the function directly. When this code is run, the code in the async functions is run as expected. It's very common to return some values from async functions. How should we fetch the return value from an async function? It's actually very straightforward. We just need to assign the whole await command to a variable, and the return value of the async function will be assigned to the specified variable. Finally, let's see how to run multiple coroutines concurrently. This is where coroutines can be easily misused. We first define an async job function in which it simply sleeps for 1 second. Note that we cannot use the sleep function from the time package, but need to use the one from the async io package. In the main function, 3 jobs are started with the await keyword. When this code is run, you may be surprised that the code is actually run synchronously. A new job can only be started when the previous one is completed. This is not what we want. We want them to run concurrently. So what is the issue? The reason is just with the await keyword, which will pause the execution of the function until the awaited task is completed. As a result, the coroutine objects created are awaited one by one, and a new one cannot be started until the previous one is completed. To run the coroutines concurrently, we need to first collect the coroutines in a list, which is commonly called tasks, and then call the gather function from the async io package to run them asynchronously. Note that we need to use the star operator here to unpack the list for the gather function. Also note that the gather function should be awaited rather than the coroutine objects. When this function is run, the coroutines are run concurrently as expected. This is it for this video. We just covered the fundamentals of async functions in this video, and will introduce more practical usage in other videos. If you enjoyed the video, please subscribe to my channel for more content.